So I want to, how many people have heard about the Smart Manufacturing Leadership Coalition? About a third or so. So that's the first set of the slides. Is I really want to talk to you about what it is, and then hopefully it kind of puts the icing on the cake for this afternoon, since we've talked about the consortium and we've talked about Internet of Things. The Smart Manufacturing Leadership Coalition was a group of people that got together in about 2006 to struggle with this idea of trying to advance the concept of manufacturing. And the difference that I think we represent from what we've heard in the earlier speakers is we've come at it from a process industries perspective instead of a discrete perspective. And so we met together with oil and gas, hybrid industries like food, and we started to share our problems about how do we advance the topic of manufacturing? How do we advance our supply chains? How do we advance our technologies? How do we try to improve the competitiveness of American manufacturers? And if you think back of 2006 and 7 and 8 and what was going on in the economy at the time, as everything was crashing and the financial market was not doing very well, people were talking about jobs and trying to really revitalize American manufacturing. And so that was the beginning of this smart manufacturing concept. And ultimately, it was not so much about the execution of manufacturing or the execution of a supply chain. It was really about the optimization. And so when you think about it, when we started, it was about how could we take advanced modeling and technologies and predictive kinds of thinking and bring those to the table. How could you take universities and PhDs and all these smart folks in the world and get them to work on your problems? We ultimately came from a collection of manufacturers that basically have closed environments. And so you think about it in yesterday's world, we all built our own ecosystems. How many people in the world can help us solve our manufacturing problems? Only a handful of people, right? The only people that can help you solve your problems are ones that know your ecosystem. They know your technologies, they know your networks, they know your data, they know that. So as an example, if you're trying to model your system, who are the modelers in the world that can help you optimize your system? Very few. If you're lucky enough to be in the oil and gas industry and you've got a lot of universities that understand some of that technology, you have PhD students that are working on that sort of thing. What's their ability to collect data off of a factory, analyze it in a model, spit it back into that factory, and actually make your plant run better? That's where we started from. So you take a look at it and say, well, how would we go and do that? If that's kind of the framework, and I'll weave in the Internet of Things and how that kind of plays into this landscape, because these are very synergistic concepts, but how does that play in? We need to have an open architecture for manufacturing. And I'll talk about why that's important in a few slides. And ultimately, at the end of the day, when you're trying to get to this next generation, this next revolution, where information and acting on that information is really the thing that is separating the men from the boys in this equation, you absolutely have to have real time, and I really appreciate, Richard, the way you said that. I use the word speed of business, because the real time is really, I need to act on it now. So there's a deadline, and that deadline is now. And it could have taken me 24 hours to get to now, or it could have taken me 24 milliseconds to get to now. But now is when I need to act, and acting is what I'm trying to do to make it smart. The other thing that I need to do to make it smart, and this is the thing I'll talk about in a couple other slides, is I cannot just be connected through the Internet of Things. I have to add context. And I haven't heard the word context talked about yet this afternoon, but I'll share a few words on what context means. So this is our quick timeline. 2006-ish, 2007, we ran workshops where a bunch of us are getting together in a room like this. We got together a room like this in Washington, D.C., and said, what are your problems? And we kind of shared our problems. And we developed a roadmap through that process. And then ultimately, at the end of the day, you can only do so much with thought leadership. if you're going to try to actually build something, if you're going to try to actually move the initiative forward. And so what we did was we formed as a nonprofit organization so that we could actually begin getting grants and getting funding and actually start to take this wave and turn it from a white paper or a set of proposals into actually work where we could actually do some things. And one of the things you're going to hear about this afternoon is you're going to hear the stories of a few of our members, as well as you're going to get a quick demonstration of where that technology base is. Because we're not just about thought leadership, we're actually about creating a software platform in an open architecture. We've had workshops. We won a Department of Energy grant in 2013 to actually build a demonstratable platform that would actually be an open platform that would solve some of these problems that we've talked about earlier today. Larry from Praxair is one of the locations in that grant, and he'll tell his story. And then ultimately, at the end of the day, what we're really trying to do is coalesce and get us to a place where we can actually wrap our arms around this open stack, this open topology, and figure out how to do it. If I take a look at General Mills for a second, so by the way, I'm a director at General Mills. I'm responsible for global reliability. I'm responsible for all the assets and improving the assets across the globe for General Mills. And if I take a look at some of my problems, and it was mentioned in an earlier speaker, this concept of seams. Ultimately, my problems are around flow. The concept of flow from the beginning of the supply chain, which is my supplier, all the way down through my plant and customer. And I'm trying to really basically optimize the flow, whether that flow be speed of time, or that flow be information, or that flow be maintaining product integrity. Again, one of the things that's a little bit different about General Mills, we make food. And in the production of food, Mother Nature decides what that ingredient's going to be. So I know you think that maybe we're too highly of a processed food company, but we do not change the state of strawberries. We do not change the state of milk. We do not change the state of grain. All these ingredients come to us from the farm. And unlike other process industries that can take processed ingredients and then turn them into very tightly coupled ingredients, ours have Mother Nature in there. And so as this flows through, we have to adjust our processes significantly based on the variations that we get from the farm. Also, we have additional pressures with the government treating food much more like a pharmaceutical. This concept of trace and recall and the whole concept of making sure we have a safe food chain is a big deal for us. In 2016, the Food Modernization Act comes into play, and we have to be able to trace above and beyond our plants in 24 hours. And so this concept of seams, this concept of having information flow from one supplier to General Mills, from plant to plant, through the warehousing systems, through our customers, et cetera, and to ensure that the product is being produced uniformly every single way, every single day, every single place is critical. And ultimately, it's turned into this. So Richard talks about the Internet of Things. For me, the Internet of Things is translated to the ecosystem of stuff. You know, and Internet of Things is kind of a random word, right? So what value do things have? About the same value stuff does. And ultimately, it's something as trivial as this. You're going to hear words this week like standards and platforms. And boy, if we could only be open, these would solve our problems. But this is what it looks like when a customer, General Mills, tries to solve its business problems using commercial off-the-shelf technology. Every solution on this map has an architecture that goes with it. So the only way to get my ecosystem of stuff down is to maybe pick one supplier with one common architecture for every problem I have. How many of you have manufacturers can have one supplier that can solve every problem you can ever conceive of? Right, so you have point solutions. You have different people that are good at different things. Unfortunately, everybody that's good at different things comes up with a platform and an infrastructure to go with it. There's a database and a network and a sensor and a million other things that have to be put together just for that point solution. What we're trying to do in smart manufacturing is get rid of this ecosystem of stuff and create an open architecture that allows the stuff to plug into it. So the concept is very similar to if you think about your smartphone, at least conceptually. It's a lot harder to do in reality. But if you think about conceptually that my smartphone has, I got 1 million applications that I could pick from. Every application did not create a new infrastructure. It's using the smartphone infrastructure. Imagine if we had a smart manufacturing infrastructure that allowed us to put these applications in and put them into our system instead of having to create a new architecture every time we do that. Any single box up there at General Mills is probably $10 to $15 million, by the way, and probably takes anywhere from 18 to 24 months to execute. So if I had an open platform that we all align to, which is not a trivial thing to do, the power of freeing up applications, this wasted energy that we have to build architecture adds no value. We need to get into the solutions to actually create the value. And if we did that, you know, we've done some surveys, and this data doesn't look dramatically different. I think it's very similar to Industry 4.0 and very similar to Internet of Things. Basically, you know, it's mom and apple pie. Right? Part of the world's problems get solved if we can do these sorts of things. Whether it be 25% reduction here, 40% reduction there, 10 times this, 2 times that. I mean, the numbers are amazing. These numbers are all done through surveys and what we've done at the Smart Manufacturing Coalition. And it gives us a reason to believe that if we actually created this and were able to execute this, that it would matter. And it does. The problem is that this isn't easy to do. Because to do all this, you know, you could argue it's a pyramid, whether it's inverted or not inverted, but at the end of the day, there's just a lot of stuff that needs to happen. You know, and we take this Internet of Things thing and we talk about data, and security is paramount in this. And you talk about devices. In the food industry, I don't even have devices to measure my attributes. I can't measure the moisture of grain as it goes through a dryer, because the moisture on the surface is different than the moisture inside. So we've got, in our industry, we don't even have, of course, sensors to do some of this stuff. So we still absolutely have offline instruments that we deal with. We still have people that are clearly in the middle of this. So I like the comment that was made that this is, it might come off as automation. This is a culture change. I exactly agree with the 4.0 comments. This is culture, and this is about people, and this is about putting the two together. And that's why the challenge is so hard. And you start at the bottom. You can talk about IoT. You can talk about trying to make this thing smart. You can talk about big data and be drowned in data. I'm collecting 50 million data points a day at General Mills. 50 million. What am I doing with that? Not much. There's a few key things that I use it, you know. When I have a problem, it solves some things. I'm probably not even collecting as much as I need to. And my IT people keep saying, well, if you don't need to, let's shut it down because data is expensive. I'm going the other way. I think I need to collect more because I need to get insight. And it's this thing about big data. It's about taking data into knowledge, into wisdom. That's ultimately the vision that we're trying to make happen here. The deal, though, is our Smart Manufacturing Leadership Coalition envisions all this, but what we really want to free up is the small and medium guys. Because those of us that are big multinational companies, even though it might cost me $10 million per box on that ecosystem of stuff, some of those boxes we can afford. Procter & Gamble can afford it. General Motors can afford it. General Dynamics can afford it. The small little guy that's eking out a profit and might make $1 million in revenue, not $20 billion in revenue, how do they become smart? How do they leverage Internet of Things? How do they leverage Industry 4.0? How do we have economies of scale that the small guy can win just as if the big guy can win? And we talk about job creation. Most of the job creation has happened in small and medium. It's not happened in large. Most large companies are going down in size. So we're trying to take these concepts that a number of us have led in our early adopters on, and trying to figure out how we turn that into a platform, and then how we try to figure out how we release that to the small and medium guys as well, to lift up everybody and change the economies of scale by an order of magnitude. So sometimes the software providers in the house aren't all that happy to hear me say that we would like to have the products be able to be implemented in a factory with 10x less cost, with 10 times the speed of deployment. And my answer to them is, then make it up in volume, right? Sell more systems. And the way you sell more is if they cost less and they do more, and they take less time to come up, then you can have more of an impact in manufacturing. And my second to last slide, the real power of all this, and we'll show you a quick demo, is really about taking this data that sits on the factory floor, whether it be maintenance data, calibration data, sensor data, production models, whether it be event data, transactional data, or real-time data, which is basically daytime value, and figuring out how to map it and add context to it. Because if it was just the Internet of Things, and all I knew that I had a temperature available on the internet, what would I do with that? I need to know the rest of the story. I need to know if my wife likes my house warm. I need to know the rest of the story around it. And whether I have maintenance data, I can't look at it raw. I need to know what product was it running. I need to know what crew was on the line. I need to know this contextual stuff. And by combining easy access to the raw data, figuring out how to bring it into the ecosystem, because they're going to have many sources. As an example, at General Mills today across the enterprise in the manufacturing space, I'm knitting together about 120 different databases concurrently to make it into an enterprise, so that I can add the context to it, so that I can put applications on and do something with it. And at the end of the day, if I don't act on it, I've done nothing. So again, another different differentiation in the smart manufacturing concept is to act on it. And then to act on it, we've had to actually put in this topic of workflow, that we actually manage the action of the work that the application is doing on it in real time, in the speed of business, so that I get the optimized results. With that, I'm going to turn it over to Denise, and she's going to talk about the Department of Energy Institute that is pending.
Thank you, Jim. Just very quickly, how many of you have heard about the U.S. government's National Network of Manufacturing Institutes initiative? Okay, there's a few of you. There's a major initiative in the United States right now to basically create a network of manufacturing institutes, spurred on by Fraunhofer Institute types of models. The President Obama took a position that he would like to see 45. There are 5 right now, I won't go into the details on it, but you can get on and Google it. They basically are funded by the Department of Defense and the Department of Energy, and they are very specific to the needs of those two agencies. The exciting thing for us is that the Department of Energy in December issued a notice of intent for their next institute, and it's called the Clean Energy Manufacturing Innovation Institute on Smart Manufacturing. And if you want information on it, you can go to DOE's website and check under the Advanced Manufacturing Office. It's very exciting for us because our format has always been the development of the platform that you're going to hear about with use cases that you're going to hear from our members in industrial test beds. And I just want to read quickly for you. It says, while many smart manufacturing technology elements exist in some form and level of maturity today, the scale of the required industry collaboration and development needed for smart manufacturing technology integration, open and interoperable platforms, and widespread cost-effective adoption of these technologies is beyond the scope of individual private sector organizations, particularly, as Jim was mentioning, for small and medium-sized businesses. And they have scoped out that the Institute should address advanced sensors, control systems and data analytics, high-fidelity, real-time, and predictive modeling and simulation, application toolkits or apps, workflow design, open architecture, open standards, open source, test beds, and then the integration of all of them. You'll see in the Institute, we currently have a $11 million cost-shared project with the Department of Energy. The Institute is a $70 million cost share, so $70 million from the government and $70 million must be provided by the Institute partnerships over a 5-year period. It's a very competitive process. Just up and down, Jim?
Yeah, page down.
Okay. So where is the coalition? We recently decided that we were going to lead a proposal team, and our format is the one that you see in front of you here. The idea is to have a hub in California, actually LA, where the platform infrastructure itself would be developed and maintained, and then we would have regional centers where the delivery of the platform support and the integrated test beds would occur directly with the clients that DOE is calling for. DOE is calling for focusing on energy-intensive industries. So that's in the United States and probably worldwide. It would be food processing, chemicals, petroleum, metals, and forest products are the major ones, as well as to focus on driving down the cost for manufacturing clean energy technologies like wind and solar, et cetera. By the way, it's a very domestic program. The focus is on creating businesses and jobs in the United States. We are in the formulation stage. The actual RFP is supposed to come out any day now. So if you're interested in participating, it takes just like our coalition members, we have practitioners, we have providers, we have academics, etc. We have organizations that do outreach. If you have an interest in participating with us in this institute, you can go to our website and or talk to us while we're here. Go to our website and send us a message, and we'll be glad to get in contact with you about it. Thanks a lot.